In this video, I'm going to explain about priority scheduling algorithm. As the name itself suggests or explains, here whichever the process is having the highest priority, that will execute it first than the lower priority process. Okay, now the next question is, what is this priority? The priority means we are giving the importance. That means when we want to execute many processes, which process to execute first, which process execute to next. So like that, so whichever we think this is the crucial, this is importance. For that we will assign one positive integer. If the positive integer is lowest number, suppose for the lowest number, so the convention, lowest number means highest priority. Okay, so highest number means lowest priority. Highest number means lowest priority. It may be whatever. Okay, so we can convert, we can use other convention also. That means lowest number, lowest priority also. But generally we use, so if we assign one positive integer to every process, so if that number is lowest number, then we say that is highest priority. If that number is highest, then we say lowest priority. So now we know what do you mean by priority scheduling algorithm. So what is the convention of this priority? And now who is going to assign this priority? That is the next question. So generally the priority can be assigned to each and every process in two ways. One is internally, another one is externally. Internally, every process is assigned what? One priority by operating system itself. Okay, so now operating system will always assign the priority on a fair basis. That means whichever the process requires very less number of resources, okay, that may assign the highest priority because it needs very less resources, so it's they can complete its task easily. That is the one criteria. So second criteria, whichever the process requires very less CPU burst time, so that may get the highest priority. Or the process which is having CPU to IO activity ratio of CPU to IO activity, which is based on that also operating system can assign the priority. That means operating system can assign the priority to every process based on the CPU burst time, based on the ratio of CPU to IO activity, based on the number of resources it requires, like that. Okay, now sometimes we wants to execute some series of processes in some order. Okay, so now here we can assign okay, that means we means user. User can assign the priority to the process during the programming itself. Okay, now again based on something like whichever we feel the importance, or so suppose I want to execute some task in so and so flow, accordingly we can assign. So this is how priority is assigned. Okay, now again this priority scheduling algorithm may be preemptive, may be what? Preemptive, or maybe non-preemptive. So that means it may be non-preemptive or it may be preemptive. That means non-preemptive means once any process, suppose assume with a given list of process, if one process is having the highest priority, if I start that, I need to complete, then only I will take the next priority process from the list. In the case of preemptive, when I currently, so now I am executing currently the highest priority process I am executing. Now after some time another new process arrived at the ready queue. At that time I need to compare the priority of the newly arrived process with the priority of the currently being executed process. Now which is, suppose the currently executing process is the lowest priority than the newly arrived process, I have to stop this, I have to take this. That's what the preemptive. Okay, now let us see both. Okay, for this now I will take some example. let us first apply non-preemptive priority process or priority scheduling algorithm. Non-preemptive priority scheduling algorithm I will apply. The given problem is these are the 5 processes are given and their burst time is given and their priority is given. According to our convention, what? If it is having the lowest number, then the highest priority. So here which is the lowest number? 1 is the lowest number. So this process is on the highest priority. So next lowest is 2. So this is the highest, highest priority. So like that. So now 5 is the highest number and it is on the lowest priority. So this is what I told. Now first, as usual, we need to write what? Gantt chart. Okay, I will start writing the Gantt chart. Now always we start with 0. Okay, now assume all these processes are arrived at the same time. Say let us say 0 time. At 0 time all the processes arrived. So now since all are arrived at the same time in this order, now you have to check the priority. Which is on the highest priority? Process 1. So process, this is 1 priority, that is process 2. So I need to execute start P2. Now P2 executes and it needs only 1 millisecond. So now it will be stopped at 1 milliseconds. Okay, done. That means now P2 is done. Now P2 is done. Next, after executing this, now process 2 is done. Now this is done. Now among the remaining processes, 3, 4, 5, 2, which is the lowest number. This is, so this is having the highest priority right now. So now I have to execute P5. After P2, now I have to start P5. Now P5 needs how much time? It is 5 milliseconds. So 5 plus 1, 6 milliseconds it will ends. Okay, now P2, P5 also completes. Now P2, P5 over, next these 2 over, next remaining is 3, 4, 5, which is lowest number 3. So the next highest priority among the remaining process is P1. So P1 I am executing. It needs 10 milliseconds. So 10 plus 6, 16 milliseconds. Now P1 is also over. Now I am having only P3, P4. Among these 2, this is having the highest priority, that is P3. So I am executing P3. So it needs 2 milliseconds. So 16 plus 2, 18 milliseconds. So finally I am left with what? P4. P4 needs only 1 milliseconds. So 18, 19. This is the Gantt chart for what? Non-preemptive priority scheduling. Now as usual, let us find out what? Waiting time. Okay, waiting time. I will start. Okay, come. Waiting time of process 1. See, P1 at what time it starts? 6. So P1 waited for 6. Arrival time is all out and 0 only. So P1 waited for 6. Next P2. P2 when it starts 0 time only starts, so it doesn't wait at anything, 0. Next P3. P3 waited for, P3 starts at what? 16 minutes, it waited for 16 milliseconds. So 16. So next P4. P4 it starts at 18 minutes, it waited for 18 milliseconds. So this is 18 milliseconds. So finally P5. P5 starts at 1, that means it waited for only 1 millisecond. So this is the now average waiting time. You add all these 5 and divide by 5. So 16, 6 plus 6, 22, 22 plus 18, 40, 41. 41 divided by 5. So this is nothing but 8.2 milliseconds. So this is the average waiting time. Okay. So now let us find out the turnaround time. So turnaround time is what? Turnaround formula is what? It's waiting time plus execution time. Okay, now we calculate this one. Now waiting time already we calculate. Execution time now 10 plus 6, 16, 1 plus 0, 1, 16 plus 2, 18, 18 plus 1, 19, 1 plus 5, 6. Okay, 19 plus 6, 25, 25 plus 18, 43, 43 plus 1, 44, 60. 60 divided by 5, this is 12 milliseconds. Average turnaround time is 12 milliseconds for this non-preemptive priority scheduling. Now let us apply for the same thing. Now we will apply what? Preemptive. Okay, now for preemptive, what and all we should have? Okay, hope you people understood this one. Okay, see, in the non-preemptive, once we start any process, even though, see, first I started this one. After that, if any other process comes which is having even highest priority than the currently executing, that we are not stopping. We are completing, then only we are taking the next one. That is what non-preemptive. Now let us apply to the same problem. Now I will apply what? Preemptive. For preemptive, what? They will give what? See, for note down, for this we got 8.2 milliseconds earlier. Now for this turnaround time is 12 milliseconds. Now I will write down the new thing. So now I will write the arrival time of the process. Arrival time of the process. Arrival time, let us assume it will... let us assume this is arrived at 0 time, this is arrived at 2, this is also arrived at, say, for example 2, and this is, say, 3, and this is arrived at 5. This is the arrival time. This is the arrival time. Now this is using non-preemptive priority. Non-preemptive. For preemptive, we should get arrival time. Now I will write the what. Now first I will write what? Gantt chart. Now at the 0 time which process arrives? 0 time, only one process arrives, that is what? P1. That is what? P1 arrives. So now I have to start P1, I don't have any choice, because at the 0 time I am having only one P1. P1 I am having, so P1 I started. But after starting at again that time 2 more process came at the same time. 2 more process came at the same time. So which are those? P2 and P3. Among P2, P3, now which one to execute first? Now this is having the highest priority 1 and 4, but currently running is 3. So among these 3 now, which is, see, at the time 2, at the time 2. At a time 2. Now at time 2, which is having the highest priority? So 3, 1, 4. So this is having the highest priority. So I have to stop P1 and have to take up what? P2. P2 I have to take, and P2 it is just 1 millisecond. At the 3rd millisecond it will complete. Now this is P2 is done. So now at the 3rd time, now I got one more process. Now I am having in my ready queue, I am having P1, P3, P4. P1, P3, P4. So let us say ready queue. P1, P3, P4. This is my ready queue. In my ready queue. In my ready queue, what? P1, P3, P4, which is on the highest priority, P13, P13, P34, 5. So 3, 4, 5, which is having the highest priority among these 3, P1. So again I started P1. P1 I started. Now after some time, again at the time 5. At the time 5, one more process. See, at the arrival time 5, at the arrival time, one more process comes, that is P5. So now comes P5, it also comes in my ready queue. Okay, now this P5 is having the priority 2, when compared to these 3, it is having the highest. Among these 4, highest priority is on P5. So I have to stop P1, I have to take what? P5 now. P5, I took P5, and P5 just did first time what? 5 milliseconds. So it completes, because after that there is no process arriving. So it will take 10. So P5 also done. Now once P5 done, it will be removed from the ready queue. Now again among P1, P3, P4. Among these 4, again which is the highest priority? P1, P3, P4, 3, 4, 5, again P1. So again I will start P1. So P1 request, already P1 is executed for what? 2 milliseconds, 2 milliseconds, totally 4 milliseconds already executed. Remaining what? 10 seconds. So that means remaining 6 seconds. 10 plus 6, 16. So now P1 is also done. So I will remove this from the ready queue. So next among P3, P4, which is the highest priority, P3. So I will take P3 in my stick. P3 requires only 2 milliseconds. So 18 milliseconds. P3 is done. Now left with, now I removed from the ready queue. Now only P4 is available. Now I will start executing what? P4. So that P4 requires only 1 milliseconds. So 19 milliseconds. If you add all these things, 19 will get. Okay, that is 19. Verified. Now this is the Gantt chart. Now according to this, now I will write waiting time. Waiting time. Okay. Now waiting time. Now first P1. So again, when we have multiple occurrences, what I told, go to the last occurrence. I got P1, again P1, P1 is there. Last occurrence is 10. So waiting time of P1 is equal to waiting time. Okay, waiting time of P1 is equal to the last occurrence starts at what? 10 milliseconds. But before that, it executes for 2 plus 2, 4 milliseconds to 10 minus 4. But this is P1 arrived at what time? P1 arrived at what? 0 time. So 0. So 10 minus 4, 6 milliseconds. So waiting time of P1 is 6 milliseconds. Okay. So next come to the P2. So P2, waiting time of P2. Waiting time of P2. So again, one occurrence. Only one occurrence, P2. Okay, only one occurrence. So now P2 starts at what? 2 milliseconds. 2 milliseconds. 2 milliseconds it starts. So it waited for 2 milliseconds. But it arrived at what? P2 arrived at what? 2 milliseconds. 2 minus 2. So 0. It doesn't wait for anything. 0 is the waiting time. So next you come to P3. So P3 again only one occurrence. So waiting time of P3 is equal to 16 milliseconds it waited and then it starts P3. But it arrived at what time? P3 arrived at what? 2 milliseconds. 16 minus 2 is equal to 14. So this is what? 14 milliseconds. Okay. Next P4. Waiting time of P4 is what? So P4 starts at what? After 18 milliseconds. That means 18 milliseconds waited, then from 18th onwards it started executed. So 18, but it never executed before that, but it arrived at P4 arrived at what? 3 milliseconds. So 18 minus 3, 15. So 15 is the waiting time of this one. So next last one, waiting time of P5. P5 starts, see again P5 only one occurrence. P5 starts at 5 milliseconds. That means it waited for 5 milliseconds. But it arrived at what? 5 milliseconds. So 5 minus 5, 0. So it is 0. So now again, to find the average waiting time, so I can add all these things. 6 plus 14, 20, 35. 35 divided by 5, 7 milliseconds. Whereas this is 8.2 milliseconds. This is 7 milliseconds. Okay. Now let us find out what? Finally, turnaround time. Okay, so this I will, okay, this is now I need to calculate what? Turnaround time. Turnaround time. We know that turnaround time, how to calculate? Waiting time plus execution time. Waiting time, I know, execution time. 10 plus 6, 16. 0 plus 1, 1. 14 plus 2, 16. 15 plus 1, 16. 0 plus 5, 5. So now again add this one. So 16, 3 16s are there. 30, 48, 49, 54. 54 divided by 5, that is 9.8 millisecond turnaround time. This is 12 milliseconds. This is 9.8 milliseconds. So this is how it is efficient, non-preemptive priority. Hope you people understand how to apply for the given same problem, how to apply non-preemptive and how to apply preemptive scheduling, preemptive priority scheduling. But what is the advantage? We know that advantage, average waiting time and average turnaround time is much lesser when compared to the non-preemptive priority scheduling. But what is the disadvantages of this priority scheduling algorithm? See, even though this process requires only one, it is executing at the last. That means, see, always the least priority process has to wait for a longer time irrespective of whatever the time it needs. So that means it will take too much of time. Suppose for example, assume it is waiting. After completing this, again one more process comes that is having the highest priority and is waiting. That means it keeps waiting. If the new process keep arriving and the newly arrived process are having lesser priority than this the process has to keep waiting for the long time, and that concept we are calling starvation. Starvation. That means it has to starve for the CPU. Okay. So to overcome that, what we'll go? We go for one concept called aging. Okay. Aging means, so after regular interval of time, if the lowest priority process keep waiting, so it did never get a chance. Okay, so after a regular period of time, the lowest priority always were increasing the priority. That means, for example, 5 increased to 4, increased to, like that, we keep on increasing the priority of the lowest priority process, so that we should make sure that every process get a chance to execute. Okay, so there's another concept of called aging. Hope you people understood the concept of priority scheduling algorithms. Suppose if you have any other problems on the priority scheduling algorithm and you have stuck in that, you please write in the comments. I will solve and I will let you know. Okay, so thanks for watching. Thank you.